Welcome everyone to AE 311. This week we're going to be discussing the design phases, specifically the design phases relevant for the process of architectural lighting design. And we'll be digging into some of the processes, some of the approaches, and some of the documentation that you're going to need for your project. In fact, that's what this lecture will focus on entirely, is your semester design projects and giving you an outline of what the rest of the semester is going to look like with respect to those projects. First off, I want to include this clarifying slide. There are many similar approaches to the idea of architectural lighting design, and there's many similar approaches. And so you can see that here. And what I've done is I've tabled up everyone's distinct opinions on how this process should look and what we should label it. So in your textbook, and this is what we're going to be relying on in this class, in your textbook, it quotes 6 design phases right here. And we're going to be taking a look at primarily the first 4 of those design phases. Now, the IES handbook has a similar approach. It uses some distinct terminology, and some of those phases kind of overlap with each other. And then building on that, we also have Sean Good, who teaches AE 461 and is an extraordinarily experienced architectural lighting designer. And these are the phases and the terms that he utilizes. So you don't need to know this whole table. I'm just providing it here to add some clarity to where these design phase approaches coincide and where they're distinct. Starting with programming. And these 3 elements that I have presented here, you could almost call pre-design if you're looking at the IS handbook. So these are the aspects that you want to address before you even get started with any work on the project. And so that's simply the project scope, in particular, what you'll be doing as a lighting designer on the project. Keeping in mind that oftentimes simple spaces like hallways and parking garages are going to just be handled by the electrical designer or by the architect themselves. And so your scope may not include the entire project. So it's important to clarify that at the outset. You also need to establish a budget. Oftentimes, you're going to establish a budget in terms of dollars per square foot. Lighting is overall a relatively small percentage of the total cost of a building, but it's important to understand your budget so that you can operate within it. And then finally, defining your project team is an important aspect, because that's going to tell you what other resources you have available, who you're working with, and what you need to do to provide them the information and support they need to get their part of the project done. So these are aspects that we're not really going to take a look at with your design project. Instead, what we're going to focus on is the design goals part of programming. And so the design goals basically come down to a couple things. First and foremost, what you're trying to do here is understand the owner's needs. And a lot of times that's actually done by the architect. So you may not actually be interacting with the project owner in any substantial capacity. That may be all through the architect, which means that in that case, you're not really just understanding the owner's needs, though that's crucial. You also need to explicitly support the architect's design goals, because usually you're on a project team reporting to an architect or an architecture team. Some of the aspects to consider up front is, first and foremost, what is the general design type or the design approach, and what is the overall architectural aesthetic of the building in question. And so this brings us back to our very first lecture on layers of light, where we discussed the differences between pragmatic, aesthetic, and conceptual design approaches. And so discussing that with the architect early on and understanding the needs of the project is pretty foundational to the whole process. Building on that, you need to understand your building site and context. For example, the lighting zone. So if you are in a high traffic nightclub type district, you're going to have a lot of freedom to get crazy with the facade lighting. But if you're in a residential district, then light control and light trespass become important considerations. So there's a lot worth knowing about the building site in context, the established architecture, and the nearby buildings that are going to educate what you want to do as a designer. And then finally, this is the most important one for your projects: define the intended space uses and functions. And that's important because that's going to educate what we define our visual tasks to be. So essentially, programming is the why you apply light. So why do you apply light to anything in your project? Visual tasks. So this is the bread and butter of lighting design. And one of the very early parts of your process is defining and understanding the visual tasks in any space. You can start with the intended use and function of the space. That'll tell you most of what you need to do. However, you should also consider potential less common uses and activities that might take place in that space, so that that space can be dynamic and useful for a range of things. Consider where your occupants are actually located in the space. It might be obvious right here, but in some other spaces, particularly lobbies, it's not immediately clear where your occupants are going to be. So you need to consider where they're going to be, where they're going to move to, and why, so that you understand how you need to support them moving through and utilizing that space. And then finally, we need to understand the age of our occupants and who's going to be inhabiting this building, because the older your occupants are, the more light they're going to need to do the same visual tasks. The next aspect of programming is determining what is already known about the project. So your space layouts are something that is developed throughout the project. So it's definitely an aspect of design development as well as programming. However, oftentimes there's a fair amount already known about your project. So making sure you have the dimensions, especially the ceiling height and layout, because that's where most of the lighting equipment ends up after all. So knowing your dimensions, especially the ceiling dimensions, is a big aspect and is really going to help you get started. Known ceiling equipment, because you do have to coordinate the lighting with the other elements in the ceiling, say diffusers for the HVAC system, AV equipment, sprinklers, fire alarms. There's a lot of equipment in the ceiling, and you have to coordinate with all of those elements in order to make your lighting system work for the space it's actually in. And finally, of course, there are structural elements to consider, right? Both because you might be highlighting those structural elements and because you can't place fixtures inside of them. And that includes things like the structure of the ceiling itself, like trusses and I-beams, which are going to limit the way you can lay out lighting in the space. A couple more aspects, and these are not elements you're going to need to consider for your lighting design for this semester. However, these are important elements of programming as well. So daylighting is going to depend on a couple key aspects. One of them is the building orientation. So you can imagine these skylights and those big windows in the doors will have a very different impact on the space if they're south facing versus north facing. So understanding your building orientation is going to tell you what time of day and how much light you're getting through the windows in your spaces. And then also the glazing location and size. Obviously, skylights provide a very different distribution of daylight inside the space than the windows inside those doors do. And then, of course, understanding the special features of your space. So that importantly includes architectural focal points. So if you have a feature wall, if you have intended installation places for artwork, or if you just have a particularly beautiful lobby with a well-designed staircase or designed columns, you need to understand those architectural focal points and discuss those things with your architect so you can properly highlight his design work. Also important is AV equipment. So that includes, of course, projectors, but there's a variety of AV equipment, including speakers that end up in the ceiling. And of course, you don't want to ignore other aspects such as HVAC and sprinklers and other elements in the ceiling. Let's move on and talk a little about codes and standards. So I'm including this in programming, not because this is the phase of design where you apply your codes and standards, but rather in programming is where you identify which ones are relevant to your project. And there is a lot out there. We're going to look at just two important elements here. The first one is ASHRAE 90.1. That's what the cover looks like there. This is available online. So in your project files, I'll include a link to guide you to the ASHRAE website where you can download a copy of the latest version of ASHRAE 90.1 for free. Now, this is an energy code that sets limits on how much lighting power you can use. We'll take a look at that in just a moment. The other design guide, so when we're talking about design guides, the big one that's relevant to your project is going to be the IES handbook, which is actually now become the IES online library. Again, that'll be provided to you as a part of your project materials. And we're going to take a look at that in just a moment to understand how we can utilize this to educate our design and provide adequate light levels for the visual tasks we define in our programming stage. Moving on to schematic design. And the fundamental thing we're doing in this phase is establishing our design strategy. In other words, the where and how to apply light. Some approaches that I think are especially worthwhile: design charrettes, basically just the design team getting together and spitballing ideas and coming up with solutions to problems. Sketching is extremely effective, just outlining where and how you want to apply light. For example, the image on the far side here. Inspiration photos are especially useful. Go research other lighting design projects in similar buildings, in similar spaces, and take a look at what other teams have done and see what you can utilize in your project. And finally, I want to point out that this phase is concerned about light, not luminaires. We want to focus first on how we're going to apply the light, not what gear we're going to use to get us there. Because you can assume that anything you can imagine, you can find equipment for. Some of the core questions here are: how can light support the architecture in my project? For example, we can focus on direction and distribution, form and shape, like the lines up top versus the circles down here. Do we want that contrast, or do we want to bring those hard lines down into the space around us? Contrast and texture are important here, highlighting important architectural features like a granite feature wall is importantly done with grazing so you can add some shadow and depth to that texture instead of just washing it out with a floodlight. And then we need to ask, how can light support people? Naturally, the visual tasks are the first aspect of that, but we should also consider other activities in our space, things like pathfinding, and of course, the psychological impression you get when you enter that space that we usually talk about in terms of the Flynn modes. So, what Flynn mode are you applying? So, this brings me to our design criteria. And the most important aspect of this is what amount of light are we going to utilize? Fortunately, we have an excellent guide for that, and that's the IES handbook. So let's dig into the IES handbook and take a look at how we utilize it. First off, the handbook has a hierarchical organization to it. The first thing you need to figure out is what building type you're using. So we're just looking right now at common applications, but for your project, we're going to establish the correct building type and get recommendations for that type. Step two is moving down to the space type. And so the space type is the type of room and the function of the room. So in this case, let's look at a conference room. And then we have activity type, not all the time, but oftentimes the IS handbook will group particular types of activities together to make it easier to look up related visual tasks, which brings me to the last step in this process, which is our actual visual task. For example, in this case, a front screen projector and understanding what light we need to provide to make that front screen projector work. On to the design criteria. So instead of our first column over here, we're going to move over into the quantitative design criteria within the bulk of the table. So following that straight across, we see a variety of options for our design criteria. What we need to do is establish first the age of our occupants to determine which of these columns we're going to utilize. For example, here we have under 25, 25 to 65, which is the core assumption. If you don't have any reason to believe otherwise, 25 to 65 is what you need to go with. And then, of course, we have the over 65 in the third column of our vertical illuminance targets. Another aspect that's relevant here is determining whether this is a vertical surface or a horizontal surface. So in this case, we're talking about a projector. So we want to be on the vertical side. But a lot of our visual tasks are primarily horizontal tasks. And so you're going to spend a lot of time in this set of columns right here. Now that we've established which number we want to utilize, in this case, it's going to be 50 lux, we need to look at the gauge. And the reason I'm using this example as opposed to any other is because this gauge is not an average like it usually is, it's a maximum. And let's think about this. It makes sense, right? Because our task in this case is a front screen projector. So in this case, the lighting we need to provide is less lighting, not more lighting, because in order for this visual task to function properly, we can't drown out that projector screen. So this is actually going to be set as a maximum of 50 lux instead of an average because we don't want to go over that. And finally, we can move to this last set of columns right here, which is our uniformity targets. So uniformity has a lot to do with visual performance, as we discussed earlier. And so in this case, when we're talking about a front screen projector, they're going to have a fairly tight restriction on that of only 2:1. So that's a 2:1 max to average uniformity ratio, which means that you need really uniform light on that projector screen so that you're not creating regions of different contrast that make it difficult to read what's projected there. Okay, the other design criteria for your project is going to come from ASHRAE 90.1, which is an energy standard. So that's going to set limits on what we can use. Now, an aspect that is going to be a smaller piece of your project is the controls requirements in ASHRAE 90.1. And a big part of efficient and effective lighting systems is the controls, because a light source, no matter how efficient, uses zero energy when it's turned off. And so there's a variety of ways you can use to make your lighting equipment intelligent and adaptive to the actual occupants and use of a space. And so here's some options, and these are described in detail in this table. Now, I don't want to spend a whole lot of time here because I actually do have a dedicated controls lecture coming up in 2 weeks. So hold off on the controls aspect of your project until that point. But I wanted to point it out. And here's what that table looks like. So you can see that you have particular building or space types. Here is the lighting power density limit. We're going to come to that in just a second here. And then over here, you have a variety of control options, and not just options, but actually control requirements within ASHRAE. So it's going to require that you utilize certain control strategies because they're extremely effective at reducing energy consumption. The simplest of which is simply local control. All local control means in this case is that you actually have a switch or a dimmer in the space with the lights that it's controlling. And we can get into more detailed options in the rest of the table, but we're going to save that for the controls lecture in 2 weeks. The more important aspect of ASHRAE 90.1 for your project is the lighting power density requirements. Now, I'm actually using an older table here just because it's easier to read for this lecture. So it won't look exactly like this for your project, but it's a pretty helpful table right now because I'm just wanting to see a bunch of space types and the associated lighting power density limits. Now, what this is going to give you is a lighting power density limit in terms of watts per square foot. So what you need to do is take your space type, determine the square footage of that space type, then multiply it by your LPD value, and that's going to give you a value in watts. And that's the limit that you need to meet with your lighting design. So if you calculate that and you get, say, 100 watts for your space, that means you can only install 100 watts worth of lighting equipment. Now, there are two methods that are used for compliance within ASHRAE 90.1. That's the building area method and the space by space method. They, by and large, lead to very similar outcomes. The space by space method is a little more nuanced. The building area basically takes the whole square footage of the building and says, this is a hospital or this is a manufacturing facility. Take the whole square footage and you get a wattage for the entire project. Now, with the space by space method, instead of just looking at the whole building, you're defining each of the spaces within that building. For example, using a table like this, and you're going to calculate the allowed wattage in each space, sum that, and get your total allowed wattage for your entire building. Now, mind you, you're still allowed to trade wattage between spaces, even when you're using the space by space method. So this doesn't come at a penalty. And in fact, oftentimes the space by space calculation is going to give you a slightly higher wattage allowance than the building area method does. And for your project, we're going to be utilizing the space by space method, partly because we're not doing an entire building, so it's not really even applicable. Let's take a look at the design development phase, and specifically, let's discuss our equipment specification. First off, the real question here becomes once you've established your design criteria, once you've established your design strategy, the question becomes what are you going to apply light with? So, luminaires obviously is the answer to that question, but we've got a massive variety to choose from. And so, next week, we're going to dig into the zoo of luminaires that's available to us in architectural lighting design and take a look at, in particular, the cut sheets and how this allows us to customize a type of luminaire to fit our specific project. So, that's next week. And in 2 weeks, we're going to be taking a look at controls and some of the basic strategies that you see almost everywhere that allows us to create a more nuanced and responsive lighting system. Once you know, especially what luminaires you're going to utilize within your design, or at least have an idea of what luminaires you want to use, then you can start to look at the lighting layouts within your space. And the big piece here is iterative calculations. So it's pretty rare, even for me, to just throw up some light sources and get exactly the level of light that I expect and need on the wall or on the floor or the work plane. So that's why we use our modeling software, either Loom Tools and Revit or AGI 32, to predict the amount of light we're going to get in this space. And that way, we have a good idea before we start spending money of how this lighting system is going to perform. And this is an iterative process. I want to emphasize that this is an iterative process. You're going to slap your luminaires in there and you're going to look at this wall and go, oh, cool. I'm 10 times higher than I need to be. Let's start pulling out luminaires, right? And so what you need to do is place luminaires, arrange them, make some calculations, check it against your design criteria, tweak your layout, and run it again. And that's what we're going to be looking at on Tuesday and Thursday is how we set up those calculation grids within our lighting software so that we can get that fast feedback and understand the performance of what we're specifying. Something that's outside of the scope of this class is daylight simulations. And this is a big part of model development because the way that daylight interacts with your space is going to change the way your lighting system functions and change the way it interacts with glazing. So this is becoming a tool that's more widely available within the lighting software. And so we'll not utilize that for your project. Your project is just going to use a night scene, but nonetheless, incorporating daylighting and understanding glazing is a big part of daytime scenes. And finally, accounting. That includes cost projections, the energy budget, in particular with respect to ASHRAE 90.1, but also the energy budget for the whole building, and expectations might be added from places like LEED, for example. We don't need to do this again for our projects, but nonetheless, this is an important part of the design development phase is understanding the cost performance of the system as well. Great. This brings us to design documentation. Several aspects that are going to be relevant for your projects and are the core of what lighting designers provide in the documentation for a building design are right here, the reflected ceiling plan, the lighting plan, which are similar but distinct, a fixture schedule, which is basically a table describing all of the luminaires you're utilizing in your project, a controls narrative, another table including narrative description that explains how the control system is laid out and how you expect it to work. And finally, renders, which is your most powerful design communication tool. Taking a look first at the reflected ceiling plan here. So there's several elements that are common to all reflected ceiling plans, and we can take a look at that right here. Obviously, what we need to start with is our ceiling grid and geometry. So you can see that here where you have an exposed section of the ceiling, which is adjacent to a set of ceiling tiles behind this suite. You also need to understand the height and materials. So that's exactly what this tag is telling us, is how high that ceiling is placed, and also giving us an idea of what that's made out of, which is going to tie back to a materials table somewhere else in the design documentation. Bringing it back to lighting, the equipment that we're going to include on the reflected ceiling plan is all ceiling mounted luminaires. Now, that explicitly does not include wall mounted or floor mounted luminaires because this is a reflected ceiling plan. Essentially, the way you should think about this is it's a section view that you take a cut right below the ceiling and you're looking straight up. So that's what a reflected ceiling plan is. You're reflecting just the ceiling. So that means necessarily that your wall mounted and floor mounted luminaires are excluded from this particular layout. You'll also want to include any ceiling mounted sensors, say occupancy or daylight sensors. And also included on this is your ceiling coordination strategy. So that's going to include all of your mechanical equipment, your sprinklers, your AV, so on and so forth. And so that's the basis of a reflected ceiling plan, is the ceiling coordination. I do want to point out real quick here the reference to designing with light. Your textbook actually has a great discussion of what goes into a reflected ceiling plan and how you can make that easy to utilize and easy to understand. That brings me now to the lighting plan. So the lighting plan is somewhat similar. This is also a plan view type thing, but we're not looking up at the ceiling. This is just a top-down view, which means it includes all of our luminaires because this is the lighting plan. So your ceiling, wall, and floor-mounted luminaires all go into your lighting plan. So that includes everything. Importantly, things that weren't included in your reflected ceiling plan. Other equipment that's important here in your lighting plan, emergency control devices like exit signs. Your controls go here. So there's a switch right there on the wall. So your controls are going to be placed on the lighting plan as well. And you can see here the P1 designation, that's letting you know what the switching group is. So you can, or actually, sorry, so you can see here the P1 is a luminaire designation. But as we dig deeper into this, we have different switch groups. So you can see here's an A switch group fixture, including that one over there. And then this line in front is a B switch group fixture, which corresponds to these switches right here on the wall labeled A, B, and C. So your switch groups or your control zones are going to be something you include on your lighting plan. And finally, oftentimes you also include your circuiting notation, which is going to show you which circuit your luminaires are located on and how they're grouped accordingly. Our fixture schedule. So our fixture schedule is a busy place. There's a lot of information on the fixture schedule. Some of the most important aspects are right here in the specification, because this is how you clearly describe which fixture this is as opposed to any other fixture. So you're going to start with the symbol type or designator, and that's what you're going to use on your lighting plan in your RCP to clearly indicate that you're using this luminaire, not the bottom luminaire, for example. You want to list the manufacturer, but the really crucial part. And this is something that I am definitely going to award specific points for in your design projects. This is the most crucial part of your fixture schedule. The complete catalog number that you get off the cut sheet for the luminaire specifies not just which luminaire it is from that manufacturer, but also which explicit variant. So, what is the lensing? Did you change the finish? Do you want a higher output package? Do you want a different CCT? All of that information is contained in the complete catalog number. And so that's a big thing that I want to see on your fixture schedule is a completely specified catalog number. The fixture description, this one's a little looser. So it describes the form and function of the luminaire, but it's not as necessarily specific as to what exactly this contains. You want to make sure to contain enough information that it's clear what this luminaire is and what it's intended to do. And finally, installation notes are good for the specification. And this really comes down to things like aiming or shielding so that the contractor is able to set that luminaire up in the way that you intended them to. Now, moving on to the other side of the table here. And again, your textbook contains some great information on fixture schedules and what they should include. So over on this side of the table, we're looking much more at performance of the luminaire and what type of light it's putting out. So you have things like the lumen output, the wattage or the voltage, the driver type, control options, and of course, my favorite aspect, the color. So at a minimum, I would like you all to include CCT as a key design consideration for your projects. And that's going to go right here in the fixture schedule. We can also take a look quickly at the controls narrative. Now, the controls narrative is going to include two major pieces. And the first one of that is the control table that you see right below me. And this one is more straightforward because you can just list your control type or the interface that you're utilizing, and you have a table of your space types. And all you need to do is list out in this table where those types of controls are being applied. And this is going to tie right back into ASHRAE 90.1 and meeting the requirements of that energy code, because one of the biggest pieces of that is establishing the right control systems for your lighting system. Second piece of this is a controls narrative, and I'm less concerned about this with your project. This can be fairly complex, right? So the controls narrative are when you're establishing detailed scenes or more advanced control systems and need a narrative description to be able to fully and adequately describe the function of those controls. That's going to be less important for your project. And this is a little more nuanced than what we're really going to get to into with AE 311. Nonetheless, I feel like it's important to point out because the sequence of operations is a very standard part of your controls narrative. And the last piece of the puzzle for today is your renders. Both AGI and Revit do produce renders. Might suggest that Revit actually does a better job of producing renders, if for no other reason than it's easier to build really rich models in Revit. However, your renders, regardless of platform, are your most powerful tool for communicating your design, demonstrating what your design is going to do to make that space amazing. So don't forget your renders and absolutely use that as a part of your iterative design process to understand the way that light is transporting throughout your space and the way that light is actually going to be perceived in your space. Well, that brings me to the end of the core design phases we're going to utilize in AE 311. Thank you for your time. And if you have any questions, I'll be around afterwards.